maybe it's only 70. All right, so common logs, natural logs, change of base, and applications, okay? So first off, we all need to be able to use a calculator to find any log. Oh, there we go. So log of 1,000, if we thought of this exponential form, remember this is saying 10 raised to some number will equal 1,000. Okay, because this is log base 10. There's no base written after the log. It's always log base 10. So this is saying 10 raised to what equals 1,000? Anybody have that mental math? 10 times what is 1,000? Okay, so 3 times, 10 times 10 times 10. So this one would equal 3. Natural log. So natural log is log base E of 142. So this is saying E raised to what is 142? All right. That one doesn't simplify nicely. Exact answer is simply log of 142. If we were to put it into our calculator and approximate, ends up being 4.96 approximately. Now number 3, natural log of E cubed. So natural log again is just log base E of E cubed is what this is saying. So exponential form, I know this is E to the something equals E cubed. Well, that something would have to be 3. So this one is also 3. But we could use our calculator. That's what I even said on there. Use your calculator. So we need to be able to work with our calculator to do logs and natural logs. And also if it's a log that's not a base of 10, we're going to talk about how we can solve those if the calculator we have only does log base 10. Okay, so the common log is simply that log base 10. So if you ever see it as just log of x, it is, without being written, it's log base 10 of x. Just like that x, we wouldn't write as x to the first power. It's not written, but we know it's x to the first power. Natural log. So again, natural log is simply a log base E. And I don't know, just by habit, whenever I'm working with logs, I usually work with natural log instead of log. I mean, either way it works. Okay, but if I'm evaluating, and we're going to get into solving equations tomorrow, and when I'm actually solving equations, I'll use natural log instead of log more often, but they work the same. Okay, but again, that E is a number. Okay, so E is not a variable. E is 2.71, and then it continues on from there. Okay, so E is a number, just like pi. Pi is a number, 3.14. What is natural log of E? Okay, so this is saying log base E of E. What's log base E of E? Or how could we write it in exponential form? Log base E of E, it's saying E to what equals E is what that's saying. Well, the only way this would work is if it's E to the first would equal E to the first. So natural log of E is simply 1. And that relationship is helpful, okay? Because a lot of times you can work with E and natural log, depending on how the problem's set up, to kind of undo itself. I mean, it's not really undoing it, but it just becomes a useful form of 1. All right, so let's get into an application problem. So it says, in chemistry, the pH of a solution is defined as negative log of H3O plus. Find the pH, so we're trying to figure out what the pH is if H3O plus is 2.5 times 10 to the negative 4. Well, then I can just put in negative natural log of 2.5 times 10 to the negative 4th. And this negative, you can also think of this as negative 1 times log of 2.5 times 10 to the negative 4th. And you can literally type that right into your calculator. When you do log, it should open up parentheses, or you might have to open up parentheses. You can type in 2.5 times 10 to the negative 4th. Just a quick refresher on scientific notation. So this is 2.5, but when it says times 10 to the negative 4th, means we're going to go 4 decimal places to the left. And so this would be 0, 0, 0, and 0. So this is really 0.00025. So that negative 4 just means we're going to shift the decimal place 4 units to the left. If it was times 10 to the positive 4th, we'd go 4 decimal places to the right. So this is taking a negative 1 times log of a really small number, but we can put this all in our calculator, and we end up with a pH that is approximately 3.6. All right, so we can use our calculator for this one. I don't expect you to do log of 0.00025 without a calculator. Now, same setup, but now we want to find the concentration. Okay, and they tell us the pH is 7.1. So we're essentially trying to find this unknown. Okay, well, this is really negative 1 times log of x, or log of our unknown. So if we divide by negative 1 on both sides, we end up with a negative 7.1 equals log of x. And the base is not written, but we know the base is 10. So going back to our exponential properties, this is really 10 raised to the negative 7.1 equals x. So now we're solving for that piece attached with the log. Well, we're using exponents to solve for that. And we would end up with approximately 7.9 times 10 to the negative 8. Again, I don't expect you to do this without a calculator. 10 raised to negative 7.1. It'll give you the answer. And some of your calculators might give it to you in scientific notation. Some of them might give it to you as a decimal or a decimal rounded. Okay? That negative 8 simply means that I'm going this direction, move my decimal point 8 times. And so with this one, because it was 1 decimal point was essentially already over, you're going to have 7 zeros.
So you're doing it 7.5.
If you plugged in this right here, 10 raised to negative 7.1. Okay, so if you did 10 in your calculator raised to negative 7.1, that is your x. That's this piece right here, this concentration that we're trying to figure out. Okay, now change of base property. So if you have, say, a log base 7 or something like that, something that is not 10, and if your calculator only does log base 10, you can use this change of base property. So what it is, it's the log of whatever base you want it to be. If you want it to be 10, so you can say log base 10 of x divided by log base 10 of a, and it has to be in this order. Okay, the numerator is specific, the denominator's the base of your original log. So it has to be in this order. Okay, but again, change of base, I can change in my new quotient, I can put whatever base that I want there. If I want to do it in 10, if I want to do it in 200, it would still work. I could say log base 200 of x divided by log base 200 of a, and it'll get me the correct answer. Okay, so if I want to do log base 5 of 17, and my calculator does not do a log base 5, well, I could do log base 10 of 17, all divided by log base 10 of 5. Again, that order is important. 17 has to go on top, 5 has to go on bottom. Now with our calculator, we can put that in with log base 10, ends up being 1.76. Some of yours might allow you to change the base rate on your calculator, but everybody's got something different, so depending on what you have. If your calculator doesn't do it, no problem. You can still work through them. Easy enough, right? Go ahead and start on the Math Excel. Do Wednesday. Look over all your stuff from 4.4 through 4.1.